We might sometimes want to find the second derivative of y with respect to x in a scenario where we can't isolate x in the first place. So up in chapter 4, we're going to talk lots more about what a second derivative could be used for. So we're going to find them now and then use them in chapter 4. So just notice here another notation that we might use. We know another name for dy dx. We've called it in the past y prime. So just notice that that expression dy dx takes up a lot of space, feels a little bulky, but it's very specific. It makes it very clear that I've taken the derivative of y with respect to x. So we'll use y prime here, but it's our job to remember what variable we're taking the derivative with respect to. So we're going to use y prime specifically to mean dy dx, but it's our job to remember the with respect to x part. All right, so here I'm asked to find the second derivative of y with respect to x. You can't tell me the second derivative of y with respect to x until you can write me an expression for the first derivative of y with respect to x. So that's our technique. If we're going to find the second derivative, we're going to start by finding the first derivative. And I have this equation again. I can't isolate the y, so I'm going to use implicit differentiation. I'm going to take the derivative of both sides with respect to x. That's not so bad. The 3 comes down to the front. 3 times 2 makes 6x squared minus. I'm going to take the derivative of 3y squared with respect to y, which is 6y, and multiply by the derivative of y with respect to x, which I could call dy dx, or you might get to liking this notation because it takes up a little less space. We're going to use y prime. And then on the other side of the equal sign, I've taken the derivative of 7 with respect to x, and that's 0. So I'm going to try to isolate y prime. I'm going to subtract 6x squared to the other side and divide both sides by negative 6y. So I can simplify. I'm going to find y prime is x squared over y in this case. We've talked a lot about not simplifying answers when you don't need to. But one case where you might really want to simplify an answer before you move on is a case like this, where we're going to try to find the second derivative, and simplifying our first derivative before we try to use it to find the second derivative is going to make our work a lot easier. So it's worth the hassle to cancel out those negative 6's and simplify our answer to get y prime is x squared over y. So I said you can't tell me the second derivative until you've found me the first derivative. Now I found the first derivative. Let's go through this process. And we're going to find the second derivative. Let's see. Close this guy. There we go. Okay. So my first derivative, y prime, is x squared over y. I'm going to take the second derivative, which is I need the derivative of y prime. Since y prime is a rational expression, I'm going to take the derivative using the quotient rule. So it's going to be low y times the derivative of high. Well, the derivative, this is all with respect to x, derivative of 2x of x squared with respect to x is 2x. I'm going to subtract high times the derivative of low. Here's where I'm going to need implicit differentiation. High is my x squared, and the derivative of low, the derivative of y, with respect to x, is dy dx. I can use that notation y prime. So that's what's happened here. This is high d low. The derivative of y with respect to x is y prime. And this is all over low squared, so y prime in my denominator. This is a pretty good answer, but notice I haven't given the second derivative in terms of x and y. I've given it in terms of x and y and some other expression, which is called y prime. So to really give an answer in terms of the answer that we want to give, which is in terms of x's and y's only, I'm going to have to go through and substitute back in for y prime anywhere I see y prime. It's not a big deal to find it because we already found it. That was x squared over y. So I'm just going to go back and replace all of my y primes with the expression I have for y prime, which is x squared over y. This You have no obligation to simplify. I would strongly suggest leaving your answer in this form on the free response section. I wouldn't expect you would see something this long on a multiple choice problem, but if you did, you might have to simplify it so you could choose your answer choice out of the options. So that's getting a common denominator. That's not even getting a common denominator. What have we done here? Oh, that's just performing that multiplication. You might find on the AP test, if they made that a multiple choice question, they'd get a common denominator and then subtract those two fractions at the end. But preview those multiple choice answers before you make your work, do all this work, and make sure you're simplifying toward the answer choices instead of doing extra work that you don't need to do. Okay, so remember that we've shortened the textbook assignment, and we'll see you in class Monday.